All right, guys, so before we get started, we're doing more factoring today. We're going to look at two of the problems from the homework. First we're looking at is m squared plus m minus 90, problem number 3. So the first thing we need to do for this here is to see if there's a greatest common factor between the three terms. And there's not one. So we'll do our two sets of parentheses with 3 spaces. Now since the third term is negative, our signs are going to be opposite, plus and minus. Now the factors of m squared are going to be m and m. Now the factors of 90 are 1 and 90, 2 and 45, 3 and 30. 4 doesn't work, but we do have 5 and, what is that, 1, 18. 6 works, and 15, and then 9 and 10. Oh. I'm going to do 10 and 9 first. And we can check this here. M times negative 9 would be negative 9m. And 10 times m is going to be positive 10m. And negative 9m plus 10m is going to be positive 1m. Number 8, well, there's a good chance this one's probably not factorable, but we can check and make sure. Our b squared minus 4ac is negative 4, 1, 24, 124. Second square root, negative 4 squared, minus 4 times 1 times 24 is a domain error. So if, remove that, let's see what we get, negative 80. So really this is saying that that part of it's going to be negative 80. We have complex terms. So this one here is not factorable. Yep, so number 8 is the one that doesn't factor at all. There's no greatest common factor, nothing we can do with it. Factor the greatest common factor out. Yes, I gave you one of each. There's one's. There would have been a sheet like this. I can get you another one. You're welcome. Any other questions on the homework? All right. What we're doing today is more factoring. So we're going over more factoring, how to factor these here. These are going to be a little different because most all the ones that we covered yesterday, the number in front of x squared, our a value, ended up being 1 on almost all of those there. Here, we're going to cover a lot that don't have that. So there's going to be a number in front of our squared term. But even with that, our first step is to look and see, is there a greatest common factor between these three terms? 2b squared, 17b, and 21. No. Since there's no greatest common factor, we'll move on to our two sets of parentheses with three spaces. Our third step is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive, so the signs are going to be the same and match the sign of the middle term, which is also plus. So we're going to have plus and plus. Our fourth step is to find the factors of the first and third term. So we can look at 2b squared first. Well, the factors of b squared, its part, well, the only thing that multiplies together to give us b squared is b and b. That's it. Now we also need to find the factors of 2. What are the factors of 2? 1 and 2. Are there any others? No. So we just need to plug 1 and 2 in. Really, we're just plugging 2 because 1b and b are the same thing. Questions on how we found the factors of 2b squared? Now we need to find the factors of 21. Now the factors of 21 are 1 and 21 or 3 and 7. Which one of these do we want to try first? 3 and 7. Which one do we want to put with the 2? 3 or 7? 3. And we'll put 7 with the other term. And the last step is to check, because we want to check and make sure we got the correct middle term. Now we don't check so much the first term because 2b times b is going to get us back to 2b squared. 3 times 7 is going to get us back to 21 because that's where we got the factors for those there. Now if we check this here, 2b times 7 is going to be 14b. 3 times b is going to be positive 3b. And 14b plus 3b is 17b. Is that the middle term we wanted? Yes. So these are the correct factors. Now looking at this here and what we did yesterday, is this really any different? No. I still think it's good to look at these and see these so we kind of have some references between the two. But for the most part, this is the exact same thing. Yep. Okay. I think I ended up skipping the first one, but that's fine. 7x squared minus 40x, 45x minus 28. Is there a greatest common factor between these three terms? 7 and 28 does have a greatest common factor of 7, yes? But unfortunately, 7 won't go into 45. So there is no greatest common factor here. So we'll have our two sets of parentheses with three spaces. Now we need to find the sign. The third term is negative, so the signs are going to be opposite. One's going to be positive, one is going to be negative. It really doesn't matter which one's positive, which one's negative. We just have to set one as positive and one as negative. Now we need to find the factors of the first and third term. First terms are 7x squared. Well, x squared will still be x and x. Factors of 7 are 7 and 1, 1 and 7, only one set, so we just need to stick the 7 in one of the two places. Now we need to find the factors of 28. We have 1 and 28. 2 and 14. 3 doesn't work, but 4 and 7, and that's it. Now the question is, which one of these sets of factors do we want to try? 4 and 7. So we'll try 4 and 7 first. 7 and 4. Will this one work? No. We'll check it here in a second, but there's one way that we can see that this one's not going to work. There is a common factor of 7 here, so the 7x and 7. Because there is a common factor there, we could technically factor it out. But if there's not a common factor to begin with, there can't be in either one of our factors. Now, if you're solving this, and no matter how you set it up, you keep getting common factors, recheck the beginning, because there might be a common factor there we missed. Now here, I'm going to go on and check it anyways. Because if we look at this here, 7x times negative 4 is going to be negative 28x. 7 times x is going to be plus 7x, giving us negative 21x. So even though, if we didn't see that common factor, it still does not give us the correct answer. Now we can switch it to 4 and 7 and check it again. 7 times negative 7 is going to be negative 49x. 4 times x is going to be plus 4x, and negative 49x plus 4x is negative 45x. Now, just because there are common factors in one of the parentheses, there is a chance this could have worked, but the only way that this would have worked with having the common factor is if there was a greatest common factor to begin with. Does that make sense? Because that's the only way that works. But here, since there is no common factor to start with, there can't be a common factor in the factors. Questions on this here? How do we feel about these so far? Just more iterations of yesterday? All right. I'm going to skip that one. Let's look at this. Because this one here is a little bit different. Not by a lot, just a little bit. As we look at this one here, is there a greatest common factor between these three terms? Well, no. So we'll do our 2 sets of parentheses with 3 spaces. Now the third term is negative, and since the third term is negative, our signs are opposite. If the third term is negative, the signs are opposite. If the third term is positive, then the signs are the same and they match the sign of the middle term. Now let's look at the factors of the first term here. 10m squared. Well, our m squared is still going to be what? M and m. But this time, a part of the first term, we're looking at the factors of 10, which is 1 and 10 or 2 and 5. So this is the first one we've had today, where the first term actually had more than one set of factors, because up to this point it's just been 1 in the number, or just the variable itself. So here, even though we have more than one, we still just need to pick one of them. Do we want to do 1 and 10 or 2 and 5? Up here, 2 and 5. Because again, at this point it doesn't really matter, because we will check it in a minute. Now the factors of 9 are 1 and 9 or 3 and 3. Which one of these do we want to try first? 3 and 3. Now we can check this here. 2m times negative 3 is negative 6m. 3 times 5n is going to be positive 15m. And negative 6m plus 15m is 9m. Well, what we could do now is we can switch to 3 and 3, but that wouldn't do a whole lot. So what do we want to change next? So we can change the 2 and 5 to 1 and 10. We'll just put the 10 here. Because our two choices were to change the 3 and 3 or 2 and 5, we'll change the 2 and 5. Now we can try this again. 10m times negative 3 is going to be negative 30m. 3 times m is going to be positive 3m, which will give us negative 27m. A little bit closer, but not quite. Well, switching the 3 and 3 spots isn't going to change much. So we'll need to change it with 1 and 9. Where do y'all want to put the 1? Where do you want to put the 9? 9, 1. We'll try it again. 10m times negative 1 is negative 10m. 9 times m is going to be plus 9m, giving us negative m. Okay. So we can switch the 1 and 9. 1, 9. We can, yes, because 10 times negative 9 is going to be negative 90m. 1 times m is going to be plus m, giving us negative 89m. And it is indeed the correct number, but wrong sign. Whenever we get the correct number, but wrong sign, we just need to switch the signs. Questions on this here? So this here is one of the cases where I think it's easier to switch the signs. We didn't necessarily have to switch the signs. We could have left it as this here. But to get the correct numbers, I would now have to switch the 1 and 9, and then switch the 10, m and m. It is the same answer, but we had to switch everything but the signs, or we can switch the signs. I'd rather switch the signs than switch everything else. But this is the same answer. 10m plus 9 times 10m minus 1. 10m minus 1 times m plus 9 are the same answer. Questions on this here? It does, because when we start adding more factors to the first and third term, we have more that we have to check. More possibilities. Questions on these here? We ready for the next type? 28 n to the fourth plus 16n cubed minus 80n squared. All right. Greatest common factor. 4. Yes, 4 will go into 28, 16, and 80. What else will go into all three terms? Because 4 is the greatest common factor between our three numbers, but there is something else that is in common with all three. But it's actually not a number. It is a variable, because n to the fourth, n cubed, n squared is in common with all three. We do have an n in common, yes? It doesn't have to just be a number. We can also have a variable as a part of the greatest common factor. How many n's are in common with these three terms? Because how many does the first one have? 4. The second one has 3, and the last one has 2. So how many do they all have in common? 2, because it's really the amount that we can pull out. How many can we remove from each one? And with variables, when we look at the greatest common factor, when they're in common, it's whichever one has the smallest exponent. So the smallest exponent is 2. So that means we can take 2 away from each for this here. So the greatest common factor is going to be n squared. And whenever we do this, really what we're doing is dividing each one by 4n squared. And we'll come back to why it's always going to be the one with the least power here in a second. Now, when we factor 4n squared out of 28 into the fourth, well, 28 divided by 4 is 7. N to the fourth over n squared is n squared. We remove 2 away from n to the fourth. We're left with n squared. Plus, we're going to factor 4n squared out of 16n cubed. So 16 divided by 4 is indeed 4. And here we'll just have n, because when we do n cubed divided by n squared, we take 2 n's away from n to the third. We're left with n. Minus when we divide negative 80 by 4, we're left with negative 20. Then we have n squared divided by n squared, which is 1, so we have negative 20 times 1, which is just negative 20. Questions on this here? So we remove 2 n's from each one, yes? Well, what happened to the n's in the third term? They are gone, yes? So is there a variable in common with all three anymore? No. That's kind of why it's always the one with the least power. After we take all of it, nothing left. Questions on this here? Was this as challenging as y'all thought this one was going to be? Now, this here is the exact same thing as what we've been doing. The third term is negative, so the signs are opposite. So one's going to be positive, one is going to be negative. Now we need to find the factors of the first and third terms. So 7n squared, well, n squared is going to be n and n. Factors of 7, 1 and 7. So we're just going to stick 7 in one of the two spots. Factors of 20. 1 and 20. 2 and 10. 4 and 5. Which ones of these do we want to try first? 2 and 10. Where do you want to put the 2? Where do you want to put the 10? 10 in the first, 2 in the second. Now if we check this here, 7n times negative 2, negative 14n. 10 times n is going to be plus 10n. And negative 14n plus 10n is negative 4n. Since we got the correct number but wrong sign, we just have to swap the sign. And that's it. Questions on this here? How do we feel about these here? Would we like to see another one like this? Yeah. Out of the last three, I'll let y'all pick one of those. All three are factorable. The 9r squared, or 9q, or 9p squared. 9p squared r plus 73p r plus 70r. Is there a greatest common factor between these three? There is, because 9 has a factor of 3. 70 and 73 is the question if they're divisible by 3. Now, one of our ways that we can figure out if they're divisible by 3 is plugging it straight in the calculator. The other is adding the digits together and dividing by 3. So with 70, we have 7 and 0, so 7 plus 0 is 7 divisible by 3. No, so 70 is not. So this here, there is no number in common with all 3. But they do have a common factor of r, because they all have r in common. So the only thing we can actually factor out is r, leaving us with 9p squared plus 73p plus 70. The third term is positive, so the signs are the same and match the sign in the middle term. So we have plus and plus. Factors of the first and third term. So our first term is 9p squared. So we will have p and p. Factors of 9. 1 and 9 are 3 and 3. Which one do we want to try first? 3 and 3. Now we need to find the factors of 70. I'm going to start off with 1 and 70. Then we'd have 2 and 35. 3 doesn't work. 4 does not work. 5 does, because it ends in a 0. Be 1, 14. 6 does not work because both 2 and 3. 3 does not work. 7 does. 7 and 10. And that's it. Now we need to pick one of these 3 to try first. Which one? So we're trying to pick one of these here, yes? Now, the way, again, when I approach one of these here, what number are we trying to get to? 73, that's a decently big number, yes? Now, I'm not going to straight away immediately eliminate 7 and 10, because 7 and 10 could work. I would be looking at some of the bigger numbers. I would say 1 and 70 might be a little big. So we can start with 2 and 35. And try this here. Now 3p times 35 is going to be 5 carry the 1, 105, 105p. 2 times 3p is 6p, which gives us 111p. Might be a little big. Yes. So we could swap the 3 and 3 for 1 and 9. I would hold off on that. Not so much because it's not right, but the 1 and 9 is not right. But the 3 and 3, I would just make sure and go through and check the others. Because 1 and 70 ends up giving us too big. 5 and 14. If we try this here, 3p times 14. 2 carry the 1, 42p. Plus 15p is 57p. If we switch the 5 and 14, that doesn't change anything. And well, 7 and 10, 3p times 10 is 30p. 7 times 3p is plus 21p. 51p. Okay. Now the reason I do that is just to make sure, because again, 3 and 10, 7 and 10, there's been some of these here, I've thrown those out because again, I didn't think they were big enough, and it actually turned out to be the right answer. So again, it's good to check those just to make sure, okay, We've done all the combinations with 3 and 3. 3 and 3 is out. Because the only one we didn't do is 1 and 70. And if we did 1 and 70, well, third time's charm. 3p times 1 is 3p. Plus 70 times 3p is 210p. So 213p. Yeah, 70 and 1 is not it. Okay. Now we're going to switch to 3p and p. 3p. 3 and 3 for 1 and 9. All right. Factors of 70, we have all 4 again. Which one do we want to try first? 10 and 7. Yeah. 9p times 7 is going to be 63p. 10 times p is plus. And that's what we wanted. Questions on this here? How do we feel about factoring? We feel good, we feel better with this here. Now factoring will show up again and again, especially throughout pre-cal or kind of other sets. All right. Now we're not going to cover one like this here. Well, y'all remember this here, yes? This is what? Cosine, yes? Cosine squared of x plus 4 cosine of x plus 4. We're going to treat this, and I'm going to have you. We can factor this. Now, you don't have to write this down. I'm just, again, above and beyond. Because it doesn't seem like this is something that can be factored. Now, if we treat it the same way we've been treating this, there is no greatest common factor between the 3 terms. The third term is positive, so the signs are the same and match the sign in the middle term. So we have plus and plus. Now let's look at the factors of the third term. Normally we start with the first, we don't have to. 1 and 4 or 2 and 2. Now, I'm going to pick 2 and 2. Now, finding the factors of cosine squared seems like it's something that's odd and something that'd be hard to do, yes? When we square something, we're saying it's what? Multiplied by its. So something that multiplies by itself, or two things that multiply together to give us cosine squared, is cosine and cosine, because cosine squared is just cosine times cosine, yes? Now we can check and see if we got the correct middle term. Cosine of x times 2 is 2. 2 cosine of x. 2 times cosine of x is plus 2 cosine of x. And what is 2 cosine of x plus 2 cosine of x? Yeah, this is giving you an example of something where even though this doesn't look like we can still do the same things to it, we can still do the same things to it. But we're not going to get to something like that there, or as I say, above and beyond. Three, 4. Okay. 2, 3. You can just pass those straight back. The only other really interesting factoring thing is U substitution. Or, yeah, because yeah, we're not going to worry about U substitution. It's not bad.